How to calculate the final velocity of a disk rolling down an inclined plane. There are two ways. 1. Using work energy theorem. 2. Using forces and torque. For this I'll try to demonstrate the derivation of the first one. Let's take the following GIF as an example. Let's take mass of the rolling body as m, radius as r, the angle of inclination of the plane to be theta degrees, the distance covered in the inclined plane to be s, and the system to be an inclusion of Earth and disk. Background knowledge: I equals m, r squared. W equals delta E. V equals omega r. Where I equals moment of inertia, r equals radius of the body, delta E equals change in energy, v equals velocity, omega equals angular velocity. Free body diagram of the disk. 1. Frictional force. 2. Normal reaction force. 3. Gravitational force. Internal in this case, as we have taken the entire Earth and disk as a single system, therefore equals 0. Work done by each force. 1. Frictional force. Since it's rolling, the point of contact keeps changing, as such there is no displacement, hence it is 0. 2. W equals Fs cos theta, but theta equals pi/2, hence this will also be 0. Therefore total work equals 0. W equals delta U, which is equal to change in translational kinetic energy kT plus rotational kinetic energy kr plus potential energy U, which is equal final kT, initial kT plus final kr, initial kr plus final U. Initial U, since body starts from rest, initial kinetic energy equals 0 and final potential energy equals 0. Therefore the final formula would be 0 equals to final kT plus final kr, initial U, which means 0 equals half I omega squared plus half mv squared, mgh, but omega equals v divided by r and I equals half mr squared. Therefore 0 equals 1/4 of a meter v squared plus half mv squared, mgh, which is equal to 3/4 of a meter v squared mgh, which means 3/4 mv squared equals mgh, or v equals square root of 4/3 gh. Therefore, using the work energy theorem, we have derived the final velocity of a ball rolling down an inclined plane, which is equal to square root of 4/3 gh. Thank you.